All right. So guys, whenever we're doing inverses, we've done this before. What do you do first? Yes, you switch the X's and Y's. So guys, I'm gonna put X here. I'm gonna write this exactly the same. Just switch X and Y. Now we solve. We're gonna get Y by itself. So what do you guys think we'll do first? Very nice. So we're gonna have X minus 9 equals all of this. Now what do? Yep. This whole thing is gonna be divided by 3. Okay, so I have X minus 9 divided by 3 equals the cubed root of Y. How do I get rid of a cubed root? Yes, you cube it. So I'm gonna cube this entire side. Guys, a misconception that I keep seeing each class do is they'll write it like this. They'll put X cubed minus 9 cubed over the 3 cubed. We're not doing it like that. Don't do it like that. Okay? Put parentheses around the whole thing and then cube it, all right? Okay, that's your answer. That's it.
Oh, right.
So your answer is the inverse is this part. Just leave it like that. X minus 9 divided by 3 cubed. That's it.
So once you get 9 alone, you get harder.
Yep. All right, so that means you guys can do the rest.
Oh,
Y'all can do it.
right.
All right, so we switched X and Y, yeah? All right, Ethan, what'd you do?
Minus 6.
Yeah.
Oh, minus 6. All right, so we have X minus 6 equals negative 1/2 Y cubed. Now, guys, what is the reciprocal of negative 1/2? Negative 2. So I'm gonna multiply this side by a negative 2, those cancel. I'm gonna multiply this side by a negative 2. So this is what we get. Negative 2 times X minus 6 equals Y cubed. Now what do I do to both sides? Cube root it. So this is your answer. The answer is the cubed root of, and if you want to distribute this, you can, negative 2x plus 12. Yes.
This whole thing.
Let's talk about finding inverses or determining whether these are inverses or not using a composition. Okay, a composition is when we plug one function into another function. So let me demonstrate what that looks like. I'm not gonna do it with these because I want you to do these on your own. Let's go back to the first example we did. I'm gonna prove that they're inverses of each other by using compositions. Okay. This was example 1. This was the original function and this is the inverse function. What I'm gonna do is I'm gonna write this again. However, I'm going to plug this function into the previous function, into the original function. So I'm going to erase that x, and in its spot, I'm going to put x minus 9 divided by 3 cubed. If I end up with x, that means I did it correctly. So let's see here. What cancels out? Yes, the cubed root cancels out with the cubed. I'm going to write down what I have now. 3 times x minus 9 divided by 3 plus 9. What cancels out? The 3's. Multiplying by 3 and then dividing by 3 cancels out. Okay? I'm left with x minus 9 plus 9. You see what cancels? These cancel. I'm left with x. This is looking good. Now, I need to plug the original function into the inverse function and also get x. If I get x both ways, that means they're inverses. Okay, so let's try it out. I'm going to erase, I'm gonna expand this, make it a little bigger. Let's make this bigger. Right, this was the inverse?
And minus 9.
Oh, it was a 9? Okay, so guys, I'm gonna erase this x, and inside, I'm gonna put the original function, 3√3 x plus 9. All right, do y'all see what cancels out? Yep, 9 minus 9 is just 0, that's gone. What else cancels out?
3.
3 divided by 3 is just 1, that cancels out. What else cancels?
The other cubes.
The cubed root cancels out with the cubed. What am I left with? Just this x right here. So when I did it both ways, I was left with x. This tells me that these are inverses of each other. These are inverses. And we used compositions to prove that they are inverses of each other. So I'm gonna have you guys use compositions to prove that these functions either are inverses of each other or are not. Okay, go ahead and give it a shot.
Wow. I'm sorry.
All right, so I'm gonna write this nice and big. 1/3, there's an x cubed minus 12. This is the original problem. I'm gonna put this inside of here. I'm gonna use a different color so you guys can distinguish it. Okay, automatically, please tell me, Luna. It's okay. What cancels?
The cube and the.
Yes, the cubed and the cubed root cancel. Perfect. All right, let's write this down. So we have 1/3 times what's left over, 3x plus 36 minus 12. Guys, Michael, what do we always do when we have parentheses? What can you do here? There we go. Distribute. There we go. All right. What's 1/3 times 3? Yep. So this is x. And 1/3, what's 1/3 of 36? 12. Do we see what else cancels now? 12 minus 12 is 0, so I'm left with x. Yay. That was just one of them. Now I'm gonna do the other one. I'm gonna write this one nice and big. Watch me do it. Instead of an x, I'm gonna put parentheses because we're gonna put something in there. Now, I'm gonna put that original function inside of here. 1/3 x cubed minus 12. Okay, Michael, again, what can I do first? So those cancel. I'm left with. Okay, and then 3 times this is what? There we go. All right, and then I'll just bring everything else down. The cubed root plus 36. All right. This cancels, yeah. And then that cancels with that. I'm left with x. So are these inverses of each other?
Yeah.
Yes, because we got x both times. Now, you guys are going to do this one. Yes, it looks a little difficult, but you can do it. I'm gonna leave this example on the board for you. All right, guys, we're gonna plug it in. So I'm gonna write this one nice and big. Thank you. All right, I'm gonna put a big parentheses for that x. Everything else is gonna stay the same. Now I'm gonna plug in this other one into these parentheses. So -1/2 times x minus 8 divided by 3 cubed plus 2.5. Okay, so let's go ahead and start. Michael, what do I do first? Like this?
Oh, I think.
And what else? I need to do it again. Yes, thank you, Kennedy. Put it to the 2.5. All right. So -2 and -1/2, what will that be? Just one. So let me write this. This is just one. This will just stay the same. And then -2 times 2.5 is -5. Okay. I'm just gonna bring everything else down. So we have under the cubed root, we had a 5. And then a +8. Okay. Now what cancels out? Yep, 5 minus 5 cancels out. So this is what we have now. 3√3 of x minus 8 divided by 3 cubed plus 8. Next, cubed root cancels out with the cubed. 3 divided by 3, that cancels out. -8 plus 8 will cancel out. I'm left with x. Let me do that step by step. Those canceled out, so I'm left with 3 times x minus 8 divided by 3 plus 8. Those canceled, so I'm left with x minus 8 plus 8. Those cancel, I'm left with x. Okay, that was the first way. Now we have to do it the second way. Okay, this is not enough, that's just halfway through. We need to guarantee x is on both. Okay, so now I'm gonna write this one nice and big and put the other one inside of it. All right, I'm gonna erase all of this. Okay, so I'm gonna write this one, -1/2. Okay. This is one of the functions. I'm gonna put this inside of it. So 3. All right, what cancels?
8 and 8.
Good, 8 minus 8 cancels, what else? Then 3 divided by 3, then what? Yep, the cubed root cancels out with that cubed. Let me write down what we have because it's getting a little messy. -1/2 times 5 minus 2x plus 2.5. All right, I have parentheses, so I'm gonna distribute it. What will this be? -2.5 plus x plus 2.5. That cancels with that, I'm left with x. So these are indeed inverses of each other. Oh. Okay, so this is our function. I'm just gonna make a table so that I can graph this. I can put in -1, 0, 1. That sounds good. Okay, what's -1 cubed? Okay, what's -1 times -1? Times a -1. So this will be -1 times 3, which is -3. Now we'll plug in a 0. If I plug in a 0 here, what do I get? 0. If I plug in a 1, what do I get? 3. Okay, let's go ahead and graph that. -1, -3 is here. 0, 0 is here. 1, 3 is here. So your graph will look something like this. Okay, so we graphed the original one. Now we're gonna graph the inverse. Well, guys, I have the table. What do I do to do the inverse table? Exactly. We're gonna flip x and y. So now this will be -3, 0, and 3. This will be -1, 0, and 1. So let's go ahead and graph the inverse. -3, -1 is here. 0, 0 is there. 3, 1 is here. So it looks like this. And that makes sense because inverses are always mirror images across the diagonal. So this point mirrors this point. This point mirrors this point. It's a reflection across the diagonal line. Nice. I believe you guys can do the rest.
And then you'll.
So this will be -1. This is a +9. This will be 0. And this will be -9. So I'll graph that one, -1, 9 will be up here somewhere.
I
0,
kinda just-
0, 1, -9 is down here, so it looks like this.
Cause I also like made that.
Okay, and then you would just flip this to get the inverse, so 9, 0, -9, -1, 0, 1.
Sama Instagram photo, yes.
It would look like
Kahit
this.
sa Instagram, yeah. Yeah. Well, I'm gonna show it to you, just come back. No, no,
So this was a homework question. Solving for Q, first I would square both sides. Square root cancels out with the square. So I'm left with Q minus 21. And I would have this 2 times. Now, if I FOIL, the square root of Q times the square root of Q is just Q. Square root of Q times 7 is just 7 square root Q plus 7 square root Q plus 7 times 7 is 49. Then you can combine the middle. This will be Q minus 21 equals Q plus 14 square root Q plus 49. These cancel out. I can move this 49 over. So this will be what, -70? Equals 14 square root of Q. Divide both sides. And then you'll get a negative something right here, a negative number. Square root of Q, then you'll square both sides.
That makes sense. Thank you.
Huh?